So here we have a system with a bolt that is undergoing a combined load, and along the axis of the bolt right there we have a force of 20 kilonewtons, and going perpendicular to that we have another force of 35 kilonewtons. So in this instance, what we are going to do, we're just going to calculate the direct stress and the shear stress. And in the next video, we're going to look at calculating the direct strain and the shear strain. So let's get into calculating the direct stress. So if you can recall, the formula that we will use to calculate direct stress is simply stress, that's the sigma symbol, equals to force divided by area. So in order to calculate direct stress, we need to ensure that the force and the area in question, they are perpendicular to each other. So when we calculate now the area of the bolt using its diameter of 15 millimeters, then we use that with the force to get our direct stress. And what that looks like, let's find the area first. So area, I'm going to use pi d squared divided by 4 is pi times diameter squared divided by 4. So that's just pi multiplied by the diameter is 15 mil. So I'm just going to keep the 15 mil. We typically would want to convert that into meters, but for now I'm just going to use the millimeter. So that 15 mil squared times pi divided by 4, which gives us 176.71 millimeters squared. So that gives us then the area of the bolt. And to work out now our direct stress, it's just going to be the force that we get there, which is 20 kilonewtons. So that's going to be 20 multiplied by 10 to the power of 3, and all divided by the area that we just calculated, which is 176.71. Now in this instance, if you would like to convert the area to meter square, then we could just multiply this here by 10 to the negative 6, or another way is we could have just converted the millimeter from the get-go into meters. So our final answer for this one is 113. I'll put 0.2 megapascal, or 113.2 times 10 to the power of 6. So that's the direct stress. Now for the shear stress, the reason we want to use the 35 kilonewtons for the shear stress is because for the shear stress, the force must be parallel to the area that we're looking at. So to do this now, we're going to use that 35 kilonewtons, and it's because that 35 kilonewtons is parallel to the area that we have. So then to calculate our shear stress, we're going to do the same thing, but this time around it's just the force that we're going to change to 35 times 10 to the power of 3, and all divided by the area that we got, which was 176.71 millimeters square. And because we're converting that to meter square times 10 to the power of 6. So what we get here for the shear stress is 198.1 megapascal. So that gives us our shear stress and our direct stress. Now in the next video, we're going to calculate the shear strain and direct strain.